I'm happy that a lot of you survived since yesterday. I hope you all had fun. I know I did. Some of you probably saw me here yesterday talking about alerting on symptoms. Today's talk is a little bit like part 2 of that, but you don't necessarily have to go through the previous knowledge. I still have to repeat a couple of things for those that were not here yesterday or don't know what Zalando is. So I'm going to start giving you a little bit of context about the company, the organization. Zalando operates in the fashion e-commerce space, currently in 17 countries, all in Europe. I don't think Serbia is one of those countries that we are in. To give you a little bit of idea of the size, the organization currently generates over 5 billion euros per year, and the number of employees is a bit big, but I'm in the technology department, so I'm going to quickly give you a bit of context how we are distributed. Our tech headquarters is in Berlin. We have a couple of tech hubs in Europe: Helsinki, Lisbon, Dortmund, and Dublin, and a couple more offices in Germany. And in the tech department, we are around 2,000 people. I am one of those, and we run a relatively large-scale platform. After the intro, I can skip into the important part, which is the whole point of the talk, which is related to the topic from yesterday, monitoring, alerting. But before I jump exactly into that, I actually want to start with a story. A long time ago, we used to run monoliths. Monoliths had a very simple operational model. Basically, they would take care of everything. For a very typical scenario where it would serve requests, it had the entire responsibility to handle that request, send the response. That was it. Another interesting aspect about the monolith was its monitoring model. By the way, I do understand that this is oversimplifying, that eventually this model had some variations, for example, for redundancy and scaling horizontally, but it was still a monolith because all of the features were in the same code. Importantly, for this talk is the monitoring. How was the monitoring done in this time? This was the era of the devs and ops silos. It's important because the devs were probably monitoring the requests, responses, if they were succeeding, if we were lucky, we were monitoring if they were fast enough. And the ops people, they were monitoring the hardware. Is the box alive? Is the monolith process up? And each one was taking care of their own stuff. And this was pretty much how things were done back then. The interesting part is that all of this was easy. It was very easy to reason about. People had very distinct responsibilities. Sometimes they collaborated. Most times they didn't. The grumpy cat. But the important part here is it was easy to reason about. Oops. The monolith itself caused trouble for the business. I think a lot of you are familiar with the problem, how we came to where we are today. One of the things is that it prevented the business from scaling further. So it caused us trouble. What did we do? How did the industry, how did we all react to that? We solved it. We came up with microservices, and this is actually a real scenario. Maybe some of you have something more complex than this. Maybe you don't. Doesn't really matter. The important part, this is not another talk about microservices. We did that thoroughly for the last decade. But the context is important because we moved from that monolithical approach. It took us some time. We find ourselves in such madness in a lot of places. How did we do the monitoring and the alerting in this new world? Was it? Yes. What we did for most of the time is that we came up with new roles. We gave people new job titles. Some call them DevOps, some call them SREs. It doesn't really matter. We could call them whatever we want. They are just getting more money. We could call them cupcake fairies if you wanted. This is not important. What didn't change was how we monitor that. So now we have this entire, and I wish that there was a slide here for this. I deleted a slide accidentally, so I'm going to try mentally describe it, because it was very similar to this one. It would just say DevOps monitoring with all of those 4 things. And it basically summarizes to exactly that. We came up with a new role. We put the label on the exact same people, by the way. We just told them, now you work in the same team and you are now all called DevOps. Needless to say, they end up doing exactly what they were doing before. Just the new role now was doing those 4 things. Monitoring the boxes, remember the example from yesterday? EC2 instance unhealthy. Some of them were doing that. Is the microservice process up? And if we're lucky, is it failing? Is it fast enough? This sounds more like now we just run a distributed monolith. When it comes to monitoring, alerting, we do exactly the same that we were doing. And now finally jumping into the example, which with this. This is an example that I kind of already used, and we talked a bit about this. It is a very typical process, a business operation that takes place in a typical e-commerce website. It's probably the most important one, because when you capture the customer, they want to place the order, they will go through something similar to this. In our case, in our organization, this is north of 60 microservices involved for this particular business operation. I understand for a lot of you, this may be too complex, or maybe I'm even oversimplifying and you even have a more complex setup. I think the example is fair. It demonstrates, for the sake of the argument, that things can look simple but still lead to a complex situation that involves actual humans. And I'm going to start with the question: when you have something like that, how are you monitoring such a microservice distributed system? Well, I do have the example. Ah, it's here. That's where it moved. Thoroughly sorry. Let's take, for example, if the accounting service has problems in this distributed system. What do you think usually I expect? This usually traverses a bunch of different teams, from the one running the front end, from the one running the checkout service, your one, the one running the order service, and eventually all of those different teams running their own services. Everyone is responsible for their stuff. And what happens if the accounting service experiences an outage? This is usually what happens. Everyone has their own set of alerts. Everyone gets paged for the same problem. For the first 20 minutes, they scatter around trying to figure out what's wrong, what's causing this. And those first minutes are just a waste of time, and you are bleeding money. This is very typical. I know that I'm emphasizing it, but this is actually very typical. I call this one the Christmas tree effect. A lot of things blinking coming up. This is almost exactly the same, except the happiness levels are different, and I'm pretty sure no one is getting any presents. The problem with this approach, which is done a lot, is a bit what I was describing yesterday, which is this leads to a lot of false positives, leads to alert fatigue, and this is usually bringing people that cannot do anything about it. And the alternative to this, for those that missed the talk from yesterday, is if you pick a good symptom for this particular scenario, and you alert on that one alone. So this was the talk from yesterday, alert on symptoms. And basically, how would this look if you were alerting on symptoms? You'd pick a place on the distributed system where the signal-to-noise ratio is high quality, and you alert there. You create one alerting rule in that particular place. In this concrete example, you'd look at, this is close to the customer, this is where the customer pain can be well measured, the signal is good, strong enough, and you would create an alerting rule there. Typical signals that you can measure are latency on errors, for example. You could create an alerting rule in that place. So now that we are alerting on symptoms, which I hope we can move to, how would this look now in the exact same scenario? The accounting service is experiencing an outage. So the alert that we created will be triggered based on the symptom, because it doesn't matter how deep in the distributed system this is happening, but it does breach the latency or the error rate on the symptom, it will be up. It looks much better than the previous one. There are no more lot of blinking lights. There is this one which is relevant, and it tells us there is customer pain, let's fix it. Do you think there is anything wrong with this approach? I wouldn't be here if it was perfect. Go ahead.
The web front-end team might not immediately know that the accounting service has the issue.
That is not it. Good. Let's try a different example. Maybe this will make it clearer. What happens if the payment service has an outage? We are alerting on the symptom there. This is still behind the symptom. It's still good. The same alert will be up, which is great. We only have one single alerting rule, and we are capturing all of those things. But this is exactly the problem, because now the team that owns this alert rule based on the symptom is getting bombarded by all of the dependency failures. This is also not sustainable. This is not okay. While we should alert on symptoms, without proper tooling and something else to support this, the owner of that alerting rule now is getting all of the paging alerts from all of the distributed system. The bigger it gets, they don't sleep a single minute. This is also not okay. And this is what this talk is about. This exact sort of pivoting around the same team, the alerting rule owner, is the problem that has not been addressed as far as I know. And we know that what we've been doing so far, which is everyone being in charge of their own alerts and being alerted when something is up, all of them, this is not okay. This is definitely not okay. And we know that the solution for that is to move to alerting on symptoms, but just blindly doing that leads to another undesired situation, which is we bomb the owner of the customer-facing service, the one that owns the alert. And this is not just me saying it. I think this tweet captures very well the essence of the problem. These so-called microservice organizations, everyone is struggling to figure this out, this distributed ownership problem, my dependencies problem, and who's causing this. This is something that is not really being addressed. But coincident or not, you can see the date. This was a couple of days ago, or less than a month ago, and this was exactly when these slides were being prepared. And it even gave us a boost that this is the right time to go and share with the world what we've been working on. We call it adaptive paging. And adaptive paging is very simple. It's an alert handler that leverages tracing causality, the causality from tracing, and the open tracing semantic conventions to page the team closest to the problem. In a nutshell, that's it. What I'm going to do now is basically try to explain how does this work. Before I go into that, because I understand that some of these things, maybe some of you have not tried it already. I already mentioned tracing, open tracing, and this is very, very important because it's all based on open tracing. For those that don't know, open tracing is a set of vendor-neutral APIs, and this instrumentation standard that you can basically pull into your application, written in pretty much any programming language, and then you instrument your code so that you can trace the operations as they happen. I will have more details because they are relevant for distributed tracing, for adaptive paging. There is much more to it, so I can only recommend, if you're not familiar with it, to search up its origins all the way to the Dapper paper, which is very, very old, and read up a little bit about open tracing. I'm going to emphasize the relevant parts here today. One of them is spans. Spans, in a nutshell, they are a named operation that records the duration of that operation, how long it takes. These are usually remote procedure calls that you do when your microservice calls another microservice. Basically just instrumented around the span, which will measure the duration. A set of spans, different spans, they will become a trace. This is the end-to-end distributed trace. Importantly is that spans trigger other spans, which trigger other spans. These things happen as a consequence. And this is a very important aspect because this is causality. This did not happen just by itself. We can look at the data and see this happened as a consequence of that one. And this is very, very important. The simple fact that this data model establishes that, this is what's going to allow us to do adaptive paging. I also highlighted another important mechanism that we take from open tracing, which is tags. What are tags? Tags are basically key value pairs. They have a type, usually strings, booleans, and numbers. And you can think about them as a way to enrich the span itself with metadata, something that provides further context, because now you are instrumenting the code, you know that you are performing an operation, and you can enrich it with certain tags and values that allow you at a later time, oh, so what happened in that request? What happened during that part of the distributed system? And this is super valuable, because you are very free. There are some constraints like those types, but you basically can add whatever you want to this, something that is useful for your business, for your use case, for your own observability of a distributed system. So in every operation will have its own set of tags. On the other hand, open tracing also has its own set of semantic conventions. And this is very interesting, because tags, they are loosely defined. It's basically whatever key you want and a type, a value for that. But there is also these semantic conventions which establish certain tag names and an expectation. What can this be used for? One of the most important ones is the arrow tag. It's easy to understand immediately. If a certain tag is tagged with an arrow tag with a value true, the operation is considered to have failed. And this is very important because by having such semantic conventions up front, now we can start doing certain things because we know that the whole tooling around us will follow those semantic conventions, and then we build something that leverages that. And this is exactly what we do with these tags. This is just a small set. The link for the page allows you to check the entire set, but this is another important mechanism for adaptive paging, because now we can have meaning around these things, which means many distributed teams, and we have over 200, they will instrument according to these things, and then we centrally just expect that. Adaptive paging is going to basically use this expectation, this set, and is going to analyze things. So this is how it comes together. In particular, now we have this distributed trace, and what we can already observe, and a computer would also be able to do that, is that in open tracing there are implicit monitoring signals. We get latency, because spans measure duration. We also get throughput, or traffic, because you are recording all of those operations, so every time you have a named operation called place order, now you also know its traffic over time, how many place orders per second are happening. So this is also important. And this is implicit, but through the semantic conventions, for example, the presence of the error tag, you can also now measure the error rate. And it's very interesting, because this gives me an opportunity to talk about the 4 golden signals. Is anyone familiar with the 4 golden signals? Some of you are, but I was prepared for that. So there is a link for the 4 golden signals, and the TLDR for the 4 golden signals is, if you cannot measure much more than this, focus on these 4 signals. It's latency, it's traffic, it's throughput, traffic is throughput, errors, and saturation. Saturation is complicated because it's very specific to the nature of the service itself, but from those 4, from tracing, we get 3 of them. And I believe those are the most important ones. In the next example, and for the rest of this talk, is going to focus on one, again, because I consider very important, which is the error rate. It's very easy to reason about. So, if you remember the alerting on symptoms situation, and this is very brief, this is a single slide for that, you can assume that you establish an SLO for your place order operation, and you want to be alerted on that symptom. So you define something like an SLO of 3 nines, successful request placing the order, and you configure such an alerting rule that will page someone, alert someone when this is breached. A disclaimer is that which tool you use to configure the alerting itself to have its own time series database to provide this for you. This is out of the scope of this talk, because this is only about the open tracing part, the one that you can use, and you can plug this to whatever tool you are using. This is just one example, and the relevant part is that you had an alert, and you can see there that the error rate breached the SLO. In that moment, an alert was triggered. And this is the relevant part, because this is the moment that this is handed over to the alert handler. So adaptive paging is an alert handler. The first thing that the alert handler cares about is a set of exemplars. It needs to either pull or already receive from your tool in the alert payload a set of exemplars of the situation. And this is very important, because now you have your distributed tracing system with all of those interconnected operation spans, and you need a couple of examples that should be representative of what's happening right now. As I said, a lot of the tools, the one that we use actually sends this already in the alerting payload, but if that's not the case, you know that you need to go and query the open tracing backend for the exact same criteria that we define for the alerting rule within the same time window of what's happening right now. So you go back a couple of minutes, for example, and you have a set of exemplars that represent the situation. And then starts the interesting process. This is a possible algorithm. This is the one that we do, which is we start at not the root span per se, but we start at the span that matches our alert criteria. In our particular case, it was we configured our alert on the place order operation on the checkout service. So we start in that one. Starting that one, and because the alert is up, we know one thing that happened, it's tagged with the error. So we started this one, and then we go recursively doing the same thing, which is for every child span, we check if he has the error tag present. As you can see, a lot of these services, the risk service, the queue operation, and the payment gateway, they don't have anything. But the accept order operation on the order service does. So we take that path. So we analyze all of those, and we know this is where we had it. We are traversing the trace. And we do this for each one of the exemplars. Then we look again, we repeat the same process. Child spans, are they tagged with errors or not? And obviously we skip those that are not. And eventually we reach the update account operation on the accounting service, and that's it. That one doesn't have any child spans anymore. That's as basic as it is. As soon as we reach the point on this traversal that we don't longer have any child, we have a probable cause. Now we identify something that has the potential of being the thing causing the symptom. So let's revisit now the examples that we went through before, which was still an improvement over the Christmas tree, and let's see how this would work. Again, the signal is still being captured exactly in the same place, where the signal-to-noise ratio is ideal. Nothing here is problematic. This is what we want. What would happen now if the accounting service has the same outage? I guess you can guess. The difference now is going to be that your alert handler is going to do exactly the process that we just went through and described, and is going to identify the accounting service, and is going to page the accounting service team instead. So that one will get the alert. No one in between those 20 minutes, which was a waste, need to gather around and, hey, what's happening? This goes directly to that team, which immediately gets in the alert payload. We just identified this because of this reason, and we think this is what's causing it. Let's again test with the payment service, the other example. Same symptom, we keep everything as it was, and without any surprise, what's going to happen in this case is that we're going to page the payment service team. This solves the problem. No more page bombing. This basically enables the alerting on the symptoms, and we fix the page bombing problem, which reduces this alert fatigue. We think this is a pretty smart solution for a serious problem. I also understand that depending on where you are in the journey, the size of your organization, the amount of teams, the distributed ownership problem, this may not be so relevant for some of you. I can guarantee you that as it grows, eventually it will become a serious problem. The truth is, even if you just use it as it is in a very 2 or 3 team size, it still helps. Because even if you consider that it's just two or three teams, we are all friends, this is fine. Well, you lose track of that, things will grow out of your control, and then it's too late and people are already angry. So this is applicable. It also increases your observability if you just adopt open tracing. So it's highly recommended. This did not go without challenges. So usually any of these things sound very nice, but for the sake of transparency, I should also add some details on what was not working, what were the challenges that we faced while coming up with this solution. First thing is that, which kind of algorithm do you use for this detection, root cause, well, tracing all the way to the root cause? Obviously, someone mentioned artificial intelligence, because machine learning. And we did think about that, but this conference was great, giving a lot of context on how we worship complexity, and we just considered that would be so complex. The set of heuristics are so simple and easy to reason about, so we went with something very easy to reason about. It is basically what I just described. Recursively traverse that, look for the certain tags with certain values, make an informed decision, continue. Obviously, because it is simple, certain things happen in real life, which alludes to the serendipity that was also mentioned in this conference, which was at one point we found out that, oh, we had 2 error paths. It can happen. Having the 2 error paths just made us improve a little bit that thing, which was, well, give it a score to each one of them. Because you have a set of exemplars, at the end you will have a weight on every different probable cause, which probably helps to select one. Because one trace could have 2 different paths, the next one only follow another one. And again, this is just probable. This is not establishing this is the cause. It's just giving the help for a team that, hey, we saw an error in your operation, can you have a look at it? So this was one of the problems. But the biggest challenge that we faced, as many different projects that are similar, was when you need to do something like distributed tracing in your organization for the first time, this requires a certain level of effort and investment. And, well, if there is no incentive, if it takes time for folks to understand the value that this brings for them, they probably won't do it. And this was one of the biggest problems that we faced, was either completely missing instrumentation or very poor quality instrumentation. There is this temptation to just pull a library from the internet and off it goes and it does magic, but then the magic is crap. It's mostly useless. And then they need to go back and then adjust things. Most of the times, even my own team jumped in and tried to help by adjusting those things. This was actually the biggest one because it basically makes it not work. So if you know distributed trace, if you have one service in between that does not instrument its code, then you get 2 distributed systems instead of 1, and this is a black hole. You can no longer proceed analyzing the trace. It's a bit terrible, and basically you stop always in the same place, paging the wrong team, which is bad. On the other hand, we came up with our own semantic conventions to help mitigate this. The peer.service tag, which exists upstream, is the one that we use that when I know that the next team did not instrument their service, I just have to leave mine with peer.service, that one, and then the algorithm will say, okay, I am the last one, I don't have child spend, but I try to call that one. So I'm delegating the problem to that team. That team will immediately say, but it wasn't me. Well, then instrument it so that we can continue. So there is an established mechanism to give an incentive to improve it. And this actually worked. People don't hate us much, and things are getting much better. Circuit breakers was another one where when you open a circuit, well, you do it deliberately as a reliability pattern, but then I become the leaf operation. Peer.service also solves that. Last but not least was, well, all of this was in the domain of operations which have attached a specific application, a microservice in your organization. But paging a certain escalation is something completely different, and we did not have this. What we had was, this service is operated by this team. Easy enough. But due to many different reasons, this does not always map to an on-call escalation. Sometimes an on-call escalation has representatives from 3-4 teams, so it's a different organical unit. And we also struggle a little bit how to map from a service, from a failed operation, into the escalation. What we did was basically augment our application registry. We have one due to the sheer amount of production applications. This is where we keep track of those, and we just augmented that to have a specific field, which is which on-call escalation covers this particular service. And this is how then we map it. Last but not least, I only covered error rate, because it's very easy. Doing the exact same thing based on latency is a challenge of its own. So I want to be transparent, and this is another disclaimer. Doing this thing based on latency, it's much, much harder. There is this thing that we can analyze, which is the critical path, which were the spans that were chain leading to the entire end user latency. But analyzing that is not so straightforward, because you don't just pick the one that was slowest. But to keep these things simple, I did not cover that. As we approach the end, this is my opinion about things, is that observability still has ways to go. The term is relatively new. Most people are still listening monitoring. Few listen about alerting. The confusion between themselves and the talk from yesterday tries to establish that these things are different. But observability as a whole, the ability to observe a system and its health, it's something that is not very mature. And there are still many ways to go. This is my opinion. This particular talk is just one very small step that I believe is going to help improve the situation. And again, because there are people at the end of this. There are humans being paged, having to wake up in the night for nonsense. And this is really not okay, in my opinion. And this just helps making that more sustainable long term. As a closing note, a question for you. Are we all on the same page? Good, this was a quicker talk than yesterday. I hope you enjoyed it. This is not open source yet. We have plans to eventually open source this, because we actually build it in a way that should be relatively easy for the world to adopt and use. For now, it is not, but all of the knowledge that you would need if you wanted to explore it was actually in these slides, which will be shared afterwards. And I probably have like 15 minutes or more for questions, if you have them. I can only see half of you because of that strong light. Well, if you don't, again, I'm going to be outside close to our Zalando booth. If not, please approach me anywhere. I'm still going to be here until the end of the day. Thank you very much for listening, and thank you for your time here today. Thank you.